Hello, I'm Michael Wybrow. In this video, I'm going to talk about a couple of core data extension topics that are sort of beyond the basics, but are really useful, interesting things to know about. The first of these is child-managed contexts. So we have talked about managed object contexts, and child-managed object contexts are a way of having a sort of sub-managed object context that's based on a primary one. So by default, core data gives us just a single managed object context, but you can have more than one. So we can create nested child contexts that's inside another one. And inside this child managed context, you can work with it as if it's a normal context. So you can add things to it, you can edit things, you can delete them. But anything you do there can be done without affecting the main context. So why would you want to do this? Well, if you've got some changes that the user's making that need to be made together as a batch, like you're adding several related things, but you only get through doing one part of it, it doesn't make sense to store that data because it's incomplete. So this is a way of working with data in an incomplete way, and then only committing to it being in the main context or in core data when you're happy with this. So if you've got a child context, it's only when you save the child context that those changes end up in the main context. And if something changes in the main context, those changes get propagated down to the child context. So this is also a way to work with objects on other queues or threads without impacting the main thread performance. And this is important in iOS because all of the UI operations are done on the main thread. So if you do a bunch of heavy database stuff like adding thousands of objects, let's say, on the main thread, your app can become unresponsive, and if it does, the operating system can kill it, and not just can kill it, will kill it, because if iOS apps are unresponsive for a short time, the operating system will just quit them, and you'll get like a force quit out of the app. Okay, so child managed object contexts. How do you create one? You say new NS managed object context. You give a concurrency type because, as I said, these can be used on the main queue or a background queue. In our case, we're just going to say main queue concurrency type. And we can take our persistent container and our view context, and we just set this as the parent property of the context. So that makes it a child context of the main one. After that, you can use it pretty much as if you would a normal context. You can insert new objects into it. You can make changes. What you can't do is you can't link objects from different contexts. So we can't say have one object in the main context, create a new object that is in a child context, and then link them together with a relationship. What we can do is if we need to set up a relationship between two things and we need to link to a new object created in a child context, we can get a copy of any existing object that's in the main context but that is scoped to the child context. And we do that by just asking the child context for an object with a particular ID, and every NS managed object has an object ID, so you can utilize this to then access the equivalent object from a different context. And in this case, we're just conditionally casting it to superhero, and that's an optional. So this will return nil if it can't be cast to that, or a value if it can. All right, so NSFetchedResultsController. These are really useful in combinations with table views. So if you have a table view that's backed by core data, and especially if things in core data can update, so they're not static, which most core data situations we have are, then this is something that you may want to consider using. So you can certainly do manual mapping between, say, lists of objects in core data and table views, but it's really useful for it to be automatic so that if something's added into core data, you don't have to be notified of that by the class that added it. You can notice it as if you just performed another fetch and saw that new data. So NSFetchedResultsController is all about handling that process for you. It watches the database and lets you know when things change. So what you do is you set up an initial fetch, like you would if you were fetching data just through the managed object context. And you give it to NSFetchedResultsController. It performs that initial fetch, but then it watches core data. And if the results of that fetch would change, so let's say you perform the fetch at the beginning, there's 3 objects, then another one that matches that fetch is added to the database. Obviously, if it was now to do the fetch, you would return 4 objects. The NSFetchedResultsController notices that, and it notifies its delegate of the changes, and it tells you just what that new object that was added was. So this is super useful because then we can make use of this and in like a table view controller or something, we can then add an additional row for the new item that has appeared in core data. So what does this actually look like? We need to create an NSFetchedResultsController. We need to tell it the type that it's actually fetching. We create a fetch request. The fetch request is just like the ones we saw before. In this case, it has a sort descriptor, same as what we talked about before with sort descriptors. The difference here is instead of just performing this fetch, we create an NSFetchedResultsController and of type person. We give it a fetch request, and we tell it the managed object context that it's going to perform that fetch request on. And we also can give it some other information on caches and things. I would suggest you just give nil for these. You don't need to use them. They're optional. And then we specify a delegate, which is a class that's going to be notified of both the initial fetch and any subsequent changes to the fetch. So that delegate will typically be whatever class cares about the changes. And that delegate needs to implement a protocol. And the protocol looks like this method that we have in here. It says controller, where controller will be the fetch results controller, did change any object, and it did change an object, sorry, and the type of that object is any, and it tells it the index path that it was changed at. So the index path, obviously, like we've talked about table views, tells you where in a table view it would need to change, and it gives you a type of change as well, and it gives you a new index path, because if you're, say, moving something from an order within core data, then it has an original position and a new position. So basically, that means we can look at the type of this, which is this NSFetchedResults change, will be one of like insert, delete, update, move, and then it's pretty easy to make use of the table view methods, insert rows, delete rows, reload rows, delete rows, and insert rows, to give it the index path. If it's being inserted at a particular position, that'll be the new index path. If it's being deleted, you give it the old index path. If it's being reloaded, it's just the existing index path. So you can see how very easily this maps with the kind of process we have with UI table view. And in terms of a demo, I won't do a demo now, but I'll do it as part of the workshop. I will give a demo of this, again relating it back to our movie example. Okay, thanks for watching. See you in the workshops this week.